Problem 4.1.12 in Broverman is a bit more challenging from a problem-solving perspective than the other problems we've done about bonds in Chapter 4. We're going to be finding the coupon rates of two related bonds that have different prices. Two bonds, each of face amount or par value 100, are offered for sale at a combined price of 240. That doesn't mean they're both 120 though. Both bonds do have the same term to maturity, but the coupon rate for one is twice that of the other. They do have the same yield though, we'll get to that. The difference in price of the two bonds is 24. Prices are based on a nominal annual yield rate of 3%. They don't say coupons are semi-annual, so the assumption is that these are semi-annual coupons, and the semi-annual effective yield rate would be 1.5%. Find the coupon rates of the two bonds. All right, so let's write down two equations. You could set up a system of equations to find the prices of the two bonds. They would have to add to 240, and one minus the other would be 24. But you can also just do a little guessing here. I hope you could quickly guess that the prices must be 108 and 132. So you don't have to actually solve that system of equations. So the cheaper one is 108. It's the one with the lower coupon rate, evidently. The face value, the face amount is 100 times the unknown coupon rate times A sub n. We do not know the term. Those would be the number of half years. The yield rate for the nominal annual rate is 3%, so the effective semi-annual rate would be that thing divided by 2 is 1.5%. And then we also have the redemption value being 100. That needs to get discounted back to times 0, multiply times v sub 0.015 to the nth power. With the other one, the coupon rate would be 2 times r instead of just r. So you'd get 200 r an 0.015 plus same redemption amount again. That would be assumed to be the face value. This is redeemable at par times v sub 0.015 to the n power. So a system of equations. What are the unknowns? The unknowns would really be r and n. We can really find v here. Though I think what I'll do instead, I think it'll be simpler to solve this system of equations for r and for v to the n instead of for n itself. Don't forget the fact that this expression would be 1 minus v to the n divided by 0.015, and I think from now on I'm not going to bother putting subscripts on the v's. Let's go ahead and divide by 0.015. The reciprocal of 0.015 is 66.6 repeating. This is 66.6 repeating times 1 minus v to the n. All right, with that out of the way, why don't we subtract the first equation from the second? Subtract the first equation from the second to get that difference 24 to be what? Well, these two things would cancel. This minus this would be 100 r an. Since this thing is that, we can also multiply 100 by 66.6 repeating and get 6,666.6 repeating r times 1 minus v to the n. I think with what I have left to do here now, so I'm going to take this equation and say this equation and solve that system for r and v to the n, and ultimately my answers are r and 2r for the two coupon rates that I want to find. I think I'll simplify things a little bit. I think I'll divide the top equation, everything in the top equation, by 100. So I'll get 1.08. Actually, so if I divide this one by 100, I don't need the 6. Okay, I don't have to do that multiplication there. Just write this as 66.6 repeating times r times 1 minus v to the n plus 100 times v to, oh no, I divide by 100, plus v to the n. And then on this equation here, I think I will divide both sides by 6,666.6 repeating. 24 divided by 6666.6666, etc. Looks to be 0.0036. 0.0036 must equal r times 1 minus v to the n. So that's starting to look simpler. Let's see, I think I'll solve this equation for v to the n in terms of r. I can divide both sides by r and then rearrange. V to the n will be, let's see, if I divide both sides by r, I get a 0.0036 r here. Bring that over to the other side as a subtraction. Bring the v to the n to the left, keep the 1 on the one side. I'm going to get v to the n is 1 minus 0.0036 over r. And I think I'll keep that as is. I won't bother getting a common denominator because now I'm going to go ahead and plug this in here and here. And when I plug it in that one, the ones cancel. And left with 1.08 equals 66.6 repeating times r times the ones cancel and the negative signs cancel. This is going to be times 0.0036 over r. The r's will cancel. Plus, I also have it plugged in here, 1 minus 0.0036 over r. Getting close here. Better write things down so I don't make a mistake. 66.6 repeating times 0.036 is evidently 2.4. Let's see, is that right? I was thinking that was different. Let's see, let me try that again. 66.6 repeating times 0.0036. Yes, it's good I checked that. 0.24 plus 1 minus 0.0036 over r. Therefore, 0.0036 over r is, this is 1.24, minus 1.08 is 0.16. R is therefore 0.0036 over 0.16. 0.0036 divided by 0.16 is 0.0225, and that is correct. So the answer to the question is the coupon rate for the lower priced one is 2.25%, and the coupon rate for the higher priced one is double that, twice the other, is 4.5%. That's what I just underlined there. Those two percentages are the answer to this question.